Thanks everyone for joining Selenium Tips and Tricks webinar. I'm Dave Hefner. Let's get started. If you're new to Selenium, this talk is probably not what you're looking for, but I have a bunch of free resources that you can take a look at to help you get started. I have a Selenium Bootcamp at this link, which is a 5-part email course that will help you get started with writing Selenium, choosing your initial programming language and everything you need to know just to get started. I also have a Selenium guidebook. It's a book that will teach you the fundamental programming concepts that you need to know in order to start writing automated tests, as well as everything really you need to know end to end in order to get a test framework stood up, have your initial set of tests written and refactored, and then plugged into something like continuous integration. And at that link, there is actually a free sample of the book, which you can get, which is the first 6 chapters for free. Of course, I have my weekly Selenium tip newsletter at this link, and it is called Elemental Selenium. And every Tuesday, give or take a day, depending on the week, I take a problem that either I've run across in my consulting practice or take a problem that one of my readers has submitted, which I haven't found a good answer for. And so what I do is I identify the problem in a long form write-up, and I talk about a solution and then give enough information just as a primer for that potential solution with pros and cons and that kind of stuff. And then I step through an example in working code. A majority of these examples are written in Ruby, which is primarily because it's definitely an approachable language. So regardless of which language you're coming from, hopefully it reads a lot like English, and the concepts can permeate through that any kind of boundary you may have. Like if you're a Java developer, Ruby will be a little simpler, but it has a lot of the similar concepts. So my hope is that even though it's in Ruby, they're language agnostic. That being said, though, I'm in the process of actively converting the tips over to other programming languages, starting with Java and then working through the other ones as well, C#, Python, JavaScript, PHP, etc. It's taking some time, but it will happen eventually. So the tips from this newsletter, I've kind of culled through and picked out 12 or 13 of them, and I want to share them with you. There's kind of a smattering of different topics. And really all of them, or at least most of them, are written against this application called the Internet. And the Internet is an open source web application that I built and I maintain that has functionality that you find on the web, both common and ugly things, which it would be helpful to have an easy endpoint to write a test against. So I have this web app so that I can write these tests and showcase it against something I control. And pull requests are welcome, and the code is on GitHub as well. So let's start with talking about headless tests, specifically executing your tests headlessly, or the act of running them without visually seeing a browser. It's a very popular approach and something that I get asked about a lot. And some of the benefits of it are that you get with certain approaches, you get faster execution times. There's potentially easier maintenance depending on how you go about it. I like to call it a poor man's test infrastructure because it's not really built ideally for scaling, but I'll talk a little bit about that in the next couple slides. And then with doing tests headlessly, you also still get to preserve the ability to take screenshots, like when there's a test failure. And so one of the first and most common ways people run their tests headlessly is using something like XVFB. And for each of these tips, there will be a link right below the title, which should take you to the long form tip write-up if you wanted to actually see this in written form. So XVFB, just a quick primer, it's short for X Virtual Frame Buffer, and really it's just an in-memory display server that it's made for Unix-like machines, predominantly Linux. It enables you to run graphical applications like a browser without a display. And it also, as I said, has the ability to take screenshots. So you would use this when you want to run a small suite of tests headlessly without actually seeing the browser on a machine that doesn't have a monitor potentially. The best example in our world for this is using something like a continuous integration server to run your tests automatically as part of a development workflow, ideally. And there's three options for using it. The first one involves running the instance of XVFB, and you have to specify a display port. And after you do that, you have to, of course, background the process. So you just make sure it's running somewhere on the machine. And then you have to tell the session, the terminal command line session, which display port you're using, which you specify when launching the application. And then you just run your test. And it will connect to, your test will connect to the browser in that display port that you specified. Now keep in mind that this approach still has the virtual frame buffer session running after the test completes, so that would stay running until you actually close it down. Some things to think about. There could be display port collisions. If you're running multiple jobs for continuous integration, multiple test jobs, and they're all referencing the same display port, you'll end up having collisions where the tests will start to fail intermittently because there are two different tests vying for the same display port. And so a workaround is to use unique values for your display port. And a good example of how to do this is to use the continuous integration build number. And on something like Jenkins or Bamboo, they make those values exposed through environment variables. And so you should be able to kind of pluck that out for each job, and in your setup specify that value, that dynamic value, when setting the display port. Alternatively, you can just use the XVFB run binary, and you just prepend that in front of your test execution command, and it will actually start and stop and set the display value for you for XVFB. And if you're fortunate enough to be using Ruby, then you can just use the headless gem and then update your setup and teardown with a little bit of code to take care of the XVFB session for you. And what that looks like in Ruby is this. In the setup method here, we are creating an instance of the headless library and starting the session. And then in the teardown method, we're destroying that session after we close the browser. And then the rest of this code is just the rest of the test itself, which involves calling setup, running the test, and calling teardown. And actually all of the examples, for the most part, follow this very simple, similar structure. It's not actually using any specific test framework, but it's using RSpec expectations to handle an assertion. So in this test, we're really just making sure that we can load a page, grab the title, and assert that it's what we expect. But if we run this, it will actually, assuming that it's on a Linux machine that has XVFB installed, will spin up Firefox in a virtual frame buffer. And then if the test were to fail, we can add in, if we wanted to, a screenshot capture here, and it would grab that image for us. But there are limitations, again, with XVFB. It only runs on Linux, and it doesn't give you any speed advantages because we're still spinning up a full browser. But with GhostDriver, we gain some speed advantages, and we can maintain headless execution, and we actually are not limited to just Linux. And so what GhostDriver is it's a Selenium WebDriver implementation that references and is built into Phantom.js. And Phantom.js is a headless full-stack web browser that's built using WebKit. And so it handles JavaScript execution and page rendering. And it's not a full browser, but it's close. And it's a fast browser. So to set it up, there's a couple steps, but before we do that, just to recap real quick, we would use it because, again, it's faster, it's useful for a CI server, and it's not limited to just Linux. So for setting it up, we would need to download the Phantom.js binary since it's built directly into Phantom.js. And we'd start Phantom.js with a WebDriver flag, which looks like this. When actually launching it, it's Phantom.js -- WebDriver and then the port that we want it to run on. And all that has to happen for this port, all you need to know is the port can be whatever you want it to be. And within normal ranges for ports, it just has to be a port that's not already in use. So you actually could run multiple Phantom.js if you wanted to and specify a different port for each of them. And then you just need to configure your test to connect to this Phantom.js instance, which is very similar to how you would connect to a Selenium remote node. So you just use Selenium remote. And you can also connect Phantom.js instances to a Selenium grid. And at this link, you can look at the documentation and see how to do that. So if we take a simple test, which has the similar structure to the last one, minus the headless gem, what's different here is we're not calling an instance of Firefox, instead we're calling an instance of remote, and we specify the URL with the port for the Phantom.js instance, which is this right here. So if we run our tests, it would actually run on Phantom.js and it would execute quickly. Okay, switching gears, let's talk a little bit about visual testing. So I've spent a good deal of time in the last 3 or 4 months researching and writing about and using visual testing in my practice, and it's really fascinating because I think that there's a perception that visual testing is hard to do, and the technology is getting a lot better to the point where it's easy to get started, and the value you get from it is actually very tremendous. So just a quick primer on what visual testing is for the uninitiated. What you do with visual testing is you check to see that an application's UI appears correctly to its users. And the goal is to find visual bugs before your users do. And by visual bugs, I mean things like font rendering issues, layout issues, just anything on the page that's out of place. And there's loads of issues that humans can spot by manually doing visual checks, but there are still loads that you'll miss as well. It's just fascinating because it's also useful for verifying content. Things like charts, dashboards, really rich pages that have a lot of functionality but also have a lot of content. And normally to test a lot of this type of stuff would involve a challenging effort from an automated functional testing perspective, just to make some simple assertions that might be brittle potentially and still not give you a ton of coverage on the page. But with a few lines of code, you get hundreds of assertions because you now are actually checking everything on the page as opposed to just 1 or 2 elements to make sure that the state of the page is as you expect. And there's at least 16 open source solutions that I've come across to get started with visual testing, and a lot of them work in tandem with Selenium. And of course, as the founder of Selenium, and as the creator of Selenium always tells me, before you can recommend a technology, you have to be able to mention something bad about it. And so there are some challenges with visual testing to watch out for. Mainly, there's 2. There's managing the complexity, because normally for web testing, we have the complexity of different browser and OS combinations, and incorporating mobile, of course, adds device, and then we deal with responsive, and we start to talk about screen sizes, and then and everything kind of goes wild. So we have that complexity when dealing with visual testing, but then we're adding in visual checks on top of that. So it almost compounds the amount of things that we have to care about. But also there are false positives to watch out for within visual testing. Things like content that shifts just a little bit, dynamic content, typos on the screen. There's plenty of use cases where visual testing might just trip up and give you, say something failed and it's clearly not a failure. Maybe it's within some sort of tolerance that you want, but maybe you increase the tolerance and then all of a sudden you miss things that were legitimate issues you wanted to catch. And so managing complexity is hard because maybe you have to stand up your own Selenium grid. You have to have your own set of devices. You have to have an infrastructure to maintain. And then for dealing with false positives, a lot of the open source tools kind of fall down at the same point with false positives. So there's 2 solutions that I use in my practice that work well. And the first one is I use Sauce Labs. Because it just is so easy to just have any device or browser that you need, and it's turnkey. The only issue is you just have to beam across the internet. So depending where you are in the world, there may be some latency, but to me it's really worth it just to get access without having to set up your own infrastructure. So on top of that, I use Applitools Eyes to do visual testing. And it's super easy to connect the 2 together to an existing test script. So you can take your existing Selenium script, add in visual testing, and get the browser or device that you care about. And then the thing with Applitools Eyes is it doesn't run into a lot of the same false positive issues that open source libraries run into. It actually catches a lot of visual defects that other solutions might trip up on. And so the point of this this example isn't to pitch you on these tools. I recommend them just because I use them and I think they're tremendous. But the hopeful thing that comes out of this is that you say, hey, maybe I should consider visual testing. And I absolutely encourage you to check out the open source tools as well, because they're all very useful. But this example I'll just step through real quick. Let's say we have an existing login test that looks like this. And we have a simple setup that creates an instance of Firefox, and then we have a teardown that quits it after the session, and then the test itself, this public void succeeded, loads a page, the login page example from the internet, and then it loads up the login form, inputs the username, inputs the password, submits the form, and then asserts that after the login completes that there is a success notification flash message at the top, just to make sure that we were able to successfully log in. Now, if we were to take this and incorporate visual testing with Applitools Eyes, it would look like this, just the top half of this test here. We pull in the very first line, you see the class for Applitools Eyes, and then create a field variable underneath the private WebDriver instance. And then in the setup, we use the eyes variable to store a new eyes session, which is referencing the eyes class that we imported. And then we set the API key, which in this case I'm actually storing in an environment variable, but you could very easily just hardcode that value if that's your preference. And then we call eyes.open and pass in the WebDriver session, and then this connects to Applitools Eyes and then returns us a WebDriver object. And in this this last line here in setup, we're actually specifying the name of the application and the name of the test. So that way we have some semantic metadata that we can reference when looking at the job dashboard. So if there's a failure, we know which test was actually running and on which application. And then in the test itself, we're adding a couple of things. We're adding these eyes.check window calls, and this is basically putting checkpoints in our workflow that we're basically telling Applitools Eyes to take a snapshot, an image of the application, and then as we run this test multiple times, we'll have a baseline after the first test run that we can accept or reject. And if we accept it, future test runs will capture an image at each of these points in the workflow and then compare them to the baseline. And then and at the end of this test method, we call eyes.close, which closes the session and actually triggers an assertion check against each of these different check windows steps. And then if at any of those points there is a failure, the test would raise an exception and give us a link, a URL to the job in Applitools Eyes. And then in the teardown, we just add a little bit of cleanup. We want to abort the session if it's not closed properly, which is just a cleanup in case eyes.close raises an exception due to a failure. So if we were to run this and we had a legitimate failure, it would look like this. This is within my IntelliJ. It's this URL here that is the URL to the job in Applitools Eyes. And if we open it, it looks like this. So if there was actually a visual anomaly, and in this case, the logout button has vanished. The way the test was written, it would pass with Selenium, where it would say, oh, I found the success flash message at the top, but it would miss this visual issue where a button just vanished for some reason. And so aside from that, we can actually do a visual diff comparison with what the page is supposed to look like, and then we can actually choose to accept or reject this new image. And if we reject it, then we clearly are saying the baseline is correct. Next time we run the test, then it should fail again if that button isn't present. But if we accept it, then we're saying make this the new baseline. So if we wanted to incorporate something like Sauce Labs and say, I want to now run this test against a different browser and compare this Firefox instance against a version of Internet Explorer and just see what the disparities are, then you would incorporate something like this, where by using Selenium's remote WebDriver and desired capabilities functionality, you can specify the browser version, the platform, as in the operating system, the name of your test, and then point it at Sauce Labs, which would give you a browser instance, just like running locally. And then you would pass that to Applitools to use for grabbing screenshots. And so then the test execution is happening not on your machine, but in two different parts of the internet. And then that's pretty much it. Your test otherwise stays the same. And this is actually a very similar configuration to how you would configure Selenium Grid. But the difference here is that the grid endpoint is in Sauce Labs behind basic auth. So we have to specify the environment variable of the username and access key, which is what I'm doing here. Again, you could also just specify a hard-coded value for those if that's your preference as well. And once you run the test, this is what it would look like. It has all the different actions with screenshots, and it actually captures a video as well. And there's, of course, the log from Selenium as well as the metadata that was passed as part of the test configuration. So I don't expect I'll be able to do it justice what visual testing is actually going to help you accomplish or what the limitations are. But I have a series of write-ups that can be useful for you to reference on your own as you dig into it. The first one is this Getting Started write-up, which actually breaks down all of the different open source solutions and steps through an example of using one of them. And then I have two different write-ups about different false positives that you'll run into, and some potential workarounds, and then where mitigation strategies just don't really work that well. And then how to add visual testing to your existing Selenium tests. And then, of course, if you're dealing with behavior-driven development, I have an example using Cucumber and incorporating visual testing. And there's still some pieces that I didn't cover in this example, which are actually covered in this write-up more thoroughly. Things like configuring your test runs so that the test name is dynamic, so you don't have to hard code that value, as well as setting the job status correctly so that when we run our tests in Sauce Labs, it'll say pass or fail when the job runs, as well as pass the correct dynamic test name. So that's it for that. And then, of course, I'd be remiss if I didn't also talk a little bit about Selenium Grid. There's several links here. So if you want more info on Sauce Labs, I have a write-up specifically about how to use them and some more about the primer behind Selenium Remote, Selenium Grid, and all of that. But specifically for Selenium Grid, I have a breakdown at tip number 52 on what Selenium Grid is and a simple example of how to stand it up and connect to it. And then I was fortunate enough to have a guest post from Dima Kovalenko, who's the author of Selenium Design Best Practices book and the core maintainer for Selenium Grid Extras, which is a library to help maintain a Selenium Grid infrastructure and do some video recording. Definitely worth a read because it has some good pointers about how to fine-tune your grid if you're already running one. Those are worth a read as well. So let's switch gears again to another topic. These next few examples will talk about how to use a proxy server. And real quickly, what that looks like is you have Selenium, and you configure Selenium to work with a browser profile. And in that browser profile, you configure it to connect through a proxy server, which you have control over. And then you run your tests through this proxy server, accessing your application that you're testing. And with something like Browser Mob Proxy, this is very easy to do. You stand it up, and then you now have a proxy server, and it has all the functionality, all the features you would need. And I'll step through a couple of different examples of why you would use a proxy server and what that gets you. So the first one is if you want to check the status codes of specific resources to see if they loaded correctly, then this is one way to do it. This functionality used to be in Selenium, and it was removed because the strategy and the focus of Selenium is to mimic human action, and checking HTTP status codes does not fit that agenda. And so this is one way to scratch that itch if that's something that you need to do. Now granted, there are better tools for the job, but this is one advantage of using a proxy server. And so the configuration looks like this. You use a proxy server to capture the traffic from your Selenium tests. And you do this by accessing what's called the HAR, the HTTP archive. And you find the relevant status code from a specific action out of this HAR. So an example would be visiting a URL and seeing if that URL returns a correct status code. And then you would assert that the status code is what you expect. So in Ruby, it would look like this. There's actually a browser mob proxy library that acts as a helpful interface between the test and the browser mob proxy. And so in the configuration, we have to create a new instance of it, and of course there's a binary file that we have to download for browser mob proxy to even use it. And so we're specifying that here, and then we're creating an instance of the proxy once it's started, and then specifying the Firefox profile and making sure we configure it to use this proxy server, and then returning that profile object. And then in the setup, when we call Selenium and specify that we want Firefox, we can pass in this profile configuration, and then we get returned a driver object for Firefox using a profile that is connecting to this proxy server. And then now that we have that, we can modify this proxy server to do whatever we want, really. And in this example, after, of course, the teardown and run actions just to make the test work, we would want to specify some means of retrieving a status code. And it looks like this top method here where we call the proxy and we say, I want to start a new HAR, a new HTTP archive, and then run some code. And then after that code runs, I want to grab the first response code entry out of it. And so when we put that to use in this run method, we're using that retrieve status code, and we're just using it when calling a get on a specific URL. And the example I'm using here is actually a web page on the internet where whichever URL you end with, the number is the status code it will return. So if you actually went to http the internet herokuapp.com/status code/200, it would return a 200. You went 500, it would return 500, and so on and so forth, whatever status code you passed it. And so here what we're doing is we're calling a get with Selenium, which visits the page, and we're wrapping it within this retrieve status code method, and it's going to return us the status code found in the proxy server HAR. And then we're just going to assert that that value that was returned is 404, because that's the value the page should return. So a more useful approach to using a proxy server is actually blacklisting. And blacklisting is really useful because it's a means to make your tests more stable and more controllable. So what it is you use the proxy server you don't just capture the traffic, you actually manipulate it for your Selenium tests. So you can identify third-party resources that are slow to load. And these are things that could negatively impact your tests that are outside of your control. Say, for instance, if you have ads from a third party, Facebook ads, something like that, you can actually find them and force them to not load. And by doing that, you would just blacklist them. And what that looks like is this. And the setup at the top is actually, all this is very similar, but there's one line that's different than the last example, and it's this one. We're calling blacklist on the proxy, and we're specifying a regular expression. And all that this is a regex that matches the URL for the resource, this third-party resource that we want to blacklist. And what happens is the proxy server, it will find anything that matches that regular expression and force it to 404, as in not load, and just return a 404 status code. And so that will dramatically speed up anything that would be slow to load. This example of the internet, of course, takes a long time to load, and so there's one specific resource on the page. So we find it, force it to 404, and then in our test we want to just make sure that it's actually returning 404. So in this example, we're actually pulling information out of the HAR file again and making sure that that piece of information was forced to 404. A lesser known approach to using a proxy server is potentially a useful way to take your existing Selenium scripts and use them to create an initial base set of load tests for JMeter. And what that looks like is you capture traffic just like before, but you want all the traffic. You don't want just a specific action. And then we want to convert that har file into a JMeter JMX file. And then once we have that, we can run this JMX file with JMeter and enact load. But really, you probably want to modify it as needed just to get it to dialed into a point that is useful for your needs. And what that looks like is similar configuration before, with setting up the proxy server, having set up and teardown actions, and capturing traffic. But the thing we want to do here is actually use the capture traffic method for our entire test, which we're doing in this run method, and we're storing all of the har in a value that at the very end, the second to last line, we can save it to a local file, and then we can convert it to JMX. And this piece of code here is what's responsible for taking it and converting the har file into a JMX file and mapping the schema. And I borrowed this and adapted it from the Ruby JMeter example that Flood.io made available in their open source library. And Flood.io is a cloud provider that handles and helps. It's very similar to BlazeMeter for doing load in the cloud. But this is just a helpful example of how to actually convert the file. And once we actually run it, we can view the har file, and this is what it looks like in the browser. All the different actions that were used. And here is what it looks like when we load up the JMX file after it's converted in JMeter. It has all the different actions here, all the external resources and all that stuff. And so we can then go in here and modify it as needed. That's pretty much it. And I'll close the proxy server conversation with broken image checking. There's a little bit of overlap with some other methods that aren't proxy servers. There's actually 3 options. We can check to see if there is a broken image outside of visual testing, like I mentioned earlier, but we can use a proxy server to check for status code. We can also use an HTTP library or JavaScript. Let's step through each of them. So with a proxy server, it would be the same configuration we've seen before, but here we're going to capture a new har, get the page, and then we want to check, we want to grab all the images, anything with a tag of img, and then we're going to iterate through each of them and match by the source tag, make sure it's img src, and then ask the HTTP archive and see if there is a bad response code. And if there is, we'll store it in a collection. And then we'll check that collection to make sure it's empty. And if it's not empty, it'll fail. They'll say there was clearly a broken image. So this is a bit heavy because we're using Selenium potentially for something that's not its design intent, right? But this still gets us the outcome we want. But there are some faster ways to do it that don't require setting up a proxy server. If we use an HTTP library, something like REST-client, or there's numerous ones in Ruby, and there's one for every programming language. So in your own programming language, find a good, reputable HTTP library. You can set up Selenium and have it load the page, and then we can store all the images just like we were doing before. But instead of using a proxy server and Selenium to check them, we can actually use this HTTP library to call a get on these URLs. And in this case, we're iterating through each one, performing a get with an HTTP library, and then checking the status code. And this is typically an order of magnitude faster and way more reliable. So we can actually use Selenium to step through an application, grab the things we want, the URLs we want to check, and then use an HTTP library, and just use them in tandem, and then key our assertions off of that. And of course, there's JavaScript, which is probably my favorite one because this is just something that's built into Selenium that you can do without any additional libraries. After you set up things, we grab the images just like before, all the different image URLs, and then we iterate through them, but we execute JavaScript to make sure that they are complete and have the correct natural width and are not marked as undefined. And because if an image is broken, right, it'll have that little X, and the image width won't be full. And so this would catch that. This would tell us if there was a failure with an image loading. And then because we can then expect to make sure broken images collection, just like before, is empty. And if it's not, it would fail. Now, switching gears again, let's talk about forgot password. I've seen some clever ways people handle this, involving tight integration within the application they're testing to grab password information out of the system. But if you don't have access to that or have that luxury, we can use something more end-to-end. And granted, when you deal with end-to-end testing, potentially with a third-party system, especially with email, that could add some maintenance and brittleness to your test infrastructure. But there's ways to kind of mitigate some challenges. And so in this example, if we take and use Selenium to load an instance of a browser and trigger a forgot password workflow and send it to a Gmail account, and then keep the browser session active, because we're assuming that there's information in this email that we're going to want to then use in this browser session. We could then go to the email and retrieve this information, and we don't have to go through Gmail's web front end, which would be a nightmare to maintain. We can actually use their API, their REST API, to get the information. And then we can pull that information out and then use it in the active Selenium session. So in this example, it's a very similar setup to just load Firefox, tear it down after the test. But the thing that's different here is this try method, where we're creating a custom loop that's going to keep trying Gmail to make sure that the email we're looking for shows up. And no need to worry about the specifics so much, just know that we basically say, I want to try, you tell how many times, and then it's going to try every 10 seconds. And then if it finds what it's looking for, it will stop trying. And if it doesn't, it will basically keep trying until it runs out of times to try. So in the actual test, here's how we would approach it. We would initiate the forgot password email by going to this example on the internet and then finding the form where there's an email input. Say, I forgot my password, here's my email, and then submit the form by clicking the button. And then we would create an instance of this Gmail API library, provide the username and password that we want to use to check an inbox. And then we would look in that inbox and look for an unread piece of mail from this no reply email address, and look for the most recent one, the last one. And then once we find it, assuming we find it, we would grab the message body and grab the raw source, the HTML out of it. And in this example, I'm pulling the URL that we want to use and the new username and password that it provided, which is a temporary username and password. So we'd scan the email for an HTTPS URL, and then strip out the special characters to grab the username and password values as well. And then we'd go back to this active Selenium session, visit the URL we pulled out of the email, find the username, password, and login, and input them, submit the form, and then we'd make sure that we're actually taken to a secure place on the website. So that's just one way to handle forgot password in an end-to-end fashion by leveraging the Gmail API. And for each programming language, there should be some equivalent to the library I'm using for Gmail here. So moving on, let's talk a little bit about A/B testing. And by A/B testing, it's also referred to as split testing. Just a quick primer. It's a simple way for businesses to experiment with an application's features so that you can see which potential change would lead to a higher user engagement. And a simple example is testing variations for a landing page of some kind to see if more people sign up. And in this kind of a split test, there would be a control, which is how the application looks and behaves normally. And then there'd be a variant, which is normally like a couple of changes that you would want to test that could potentially lead to higher engagement. Things like changing text on the page, positioning elements in a different orientation, change the color of the submit button, things like that. And then once those variants are all configured, the business would put them into rotation, and then they would start what's called an experiment. And then during this experiment, each user would see a different version of the feature. So each user would see something different. And then their engagement would be tracked. So split tests would then, these experiments would run for the length of this defined experiment until a clear winner is found. And the tracking is, of course, how they would determine that, and which one ideally would lead to higher conversions. That's how they determine the winner. If no winner is found, then they'll try new variants, and they'll keep going until there's clearly a winner. And then the feature gets updated, and then that becomes the control. Unfortunately, for automated web testing, this is really challenging if you're testing on an environment where you don't know that these tests are going on or how to get in or out of them. So the easiest thing to do is to just force your test to opt out of A/B tests altogether. An example is using something like Optimizely, which is a very common SaaS provider for doing A/B testing. And on this example app that I have called the A/B test example, there are 3 different states that the page is available in. And you can tell which state you're in because there is different header text. That's the thing that changes between each state. When you're in the control, the way the functionality should behave normally, it just says A/B test control in the header. And then for the variation, there is A/B test variation 1. And then if you're not in the test, you'll know you're not in the test because the header text will say no A/B test. So configuration, you can easily opt out of tests within Optimizely, and ideally within your own A/B testing platform, hopefully, by forging a cookie, appending a query to the URL. Those are the 2 primary ways. And then you end up being taken out of these experiments, and you know the state of the page, and that way things are not likely to change without your knowledge. And so what that would look like here would be a simple example where we load an instance of Firefox, and we wire up some simple helper methods. And then in this first example, we'll visit the example, and then we'll grab the header text, and then just for good measure, we output it just to make sure it's what we expect. And then we check. We say, I want to get either A/B test variation 1 or the control. You want to make sure you're in one of these 2 experiments, and then we add a cookie. We forge a cookie, and in Optimizely, it's just an Optimizely opt-out cookie with a value of true. And then we refresh the page, and then we grab the header text again, and then we assert that we're opted out of the session. And so we should be getting no A/B test for the header. And if we were to just do this by going directly to the page, we go to the home page, add the cookie, then go to this test page and verify that we're also there. So we can either be on the page, opt out, and refresh, or go to the home page, opt out, navigate. Either way, we still get the same outcome. And then the alternative method is just appending Optimizely opt-out equals true, which triggers a JavaScript alert, which we would dismiss. And then we would make sure that we get the header the text that we expect. So a few different ways, but very simple. You can add something like this to your test setup to make sure that you end up opting out as needed. File management. There's a couple of different things. These are pretty common. You may know these already, you may not, but dealing with things like file upload and file download. When uploading a file, I usually end up with something like this. You have a simple form that you would choose a file and then upload, but once you click that choose file button, you end up with something like this, a system dialog that's modal. This renders your Selenium tests helpless. And so there's a couple of different options when you're in this position. The first one, rather than use something, you could use something like AutoIT, which I do not advise, but a lot of people do it. And what AutoIT does is it gives you the ability to interact with these system dialog boxes. The reason I don't advise it, aside from I try to minimize any opportunity to incorporate third-party libraries, but specifically third-party libraries that tie my test to one specific platform. So if you're using AutoIT, you are basically saying, when this happens, I can only use this test with AutoIT on Windows. So as soon as you try to do tests on OS X or on Linux and you have a system dialog, you can't use AutoIT. So there's actually a better solution, and you can send the file path, the actual full URL path as a string for the file you want to upload, and put it into the form input field, and basically sidestep the need to click that button and open that system dialog. And so what that looks like in test code, you have your simple test script, but right here we have a file name and we want to get the full path, so I do that here. Load the page for the upload form, and the important part is right here. where we're saying, what's that little text field where we can send keys, where we can input text to it and pass in the full path to the file. And then once we click Submit button, we of course want to make sure that it works. So in this example, the page renders the file name that gets uploaded. And so we grab the text and then we assert that it's the correct file name. And of course, if you're using Selenium Grid or Sauce Labs, you want to take a look at the file detector method, which is what's responsible for taking a file from your local system and then passing it through a remote WebDriver to the node that you're running on to make sure that your test can interact with it. So downloading a file, the inverse of uploading, is something that I've written about quite a bit, and it's definitely something people have talked about on the internet in testing space for a while. And there are a few ways to handle it. There's, of course, the recommended approach of don't test it. There's also people who want to download files and then check content after downloading, which is a bit heavy-handed, but it depends on your use case, I suppose. But really, the recommended approach that I have is included in one of these 3 tips. So let me show you real quick what it looks like to use Selenium to download a file. I'm getting ahead of myself. Sorry, there's 2 approaches. You can configure Selenium to download to local disk and then delete the file when you're done. Or you can use an HTTP library and perform what's called a header request. You get the headers back and you can check them to make sure that the correct content type and length. And you would do this because the head request is an order of magnitude faster than using Selenium, and there's no need to actually download the file or deal with file management. So now let me show you real quick what it looks like with Selenium. This is just Firefox. And so in this example, I'm specifying a download directory and making sure it exists. And then I'm configuring Firefox. I'm configuring a profile, and then I have to modify that profile. I have to specify a download directory. I have to specify specific behavior for the folder list and how it behaves, and it's based on abstract numbers that are reasonably documented but hard to find documentation. And then we have to make sure we never have the prompt that never asks you to save to disk, which triggers a system dialog, and we have to specify the MIME type for the files that we want to download, so things like images JPEG, applications PDF. And then if it's a PDF, we have to actually disable the PDF viewer that gets set by default. So if you try to view a PDF in Firefox, it'll open in a new tab. This disables that. Then we create an instance of Firefox, and then when we click a download link, the file ends up where we expect in this download directory that I specified here. The unfortunate part about this is that this is not a configuration that's portable from one browser to the next. So for something like Chrome, it looks like this. It's of course commented out, but you have to specify it using a JSON object and then pass it in using the prefs or the options flag. And so you have to make sure you don't prompt for a download, and then you specify the download directory. Granted, this is actually a mildly simpler configuration, but it's a different configuration nonetheless. And then don't get me started with Internet Explorer because that's probably, if not impossible, extremely challenging to set up. And there's clearly a better way to do this. And then, of course, after we tear down, we want to make sure we remove the contents of the download directory to make sure that we have a clean run every time. And then if we actually were to test against the download page I have on the internet, it would look like this, where we find the download, there's like one file listed, we find the link for it, and then we download it. And then we, of course, do some tap dancing on the local file system to make sure that the file actually was downloaded and it's not empty. But it's a lot of work, and we don't have to do that. We can instead just use an HTTP library, which looks like this. And this is just it. This is the one page. We have the setup, teardown, run. Those are just the simple helper methods, but the actual meat of it is in this run do test method, where we're getting the download page, finding the link for the file that we want to download, and then calling a head request against that link. And that's it. It returns a response, doesn't even download the file, and then we check the content type and the content length. We want to make sure that the content type is the correct MIME type. In this case, it's an application PDF. And then we want to make sure that the length of the file is not empty. So make sure that it's the type we want and it's not empty. And that's usually good enough to get you most of the way there, most of what you need. But you also have to be cognizant that you need to download secure files sometimes. And so when that happens, you have to do something like this, where you have to pull the actual cookie for the session you're in out of Selenium and then pass it into your headless connection, sorry, your HTTP library connection that's performing the head request. And that's this line right here, where we're basically still calling a head request on that link, but we're specifying a cookie. And the cookie that we're referencing was actually pulled 2 lines before it, where we say manage.cookie named rack session, because in this example we're using a rack application. Other than that, everything else stays the same. And then for your own programming language, there's of course numerous ways to handle the same thing. But within Selenium, you have the same functionality for managing cookies in every programming language. So you should be able to pull the session out. The challenging part, I guess, is just figuring out within your application what's the proper cookie set and how sessions are handled to make sure you can do that, and then plug it into the HTTP library of your choice. And if you really want to make this fancy, you could create some method that makes it easy to auto-detect the MIME type based on the file extension, which I do in this content type method. And then I update the test method I just showed you so that it's actually auto-detecting. So it's more reusable code. And we're starting to get to the end here, so I will close with a couple pieces here, which are ways to add additional output to your tests to hopefully make your test debugging a little bit easier. So here we go. The first one is you can highlight elements. And an easy way to do that is to use JavaScript. And what that looks like once we have a simple test set up and just want to create a method that will highlight an element, and we can specify a duration, how long we want that element to stay highlighted. And so what happens is we'll grab the original styling for a specific element that we want to highlight. And then we can use JavaScript to add styling, a dashed red border around this element. And then we add this little loop to basically revert it back to the original style once it's done. So that way it's not permanent. So if we have multiple elements, we can have it style it and then have it unstyle it. So we can very easily then in a test method do something like this. We can get a page and then we say, I want to highlight this specific element. And what that looks like applied is this. And this is an example with a large and deep nested DOM. And by finding the sibling of 2, 3, we can see that it just highlights it in a dashed method. So super helpful if you wanted to add this into your test setup using numerous ways to do this, but you can basically add some kind of a debug flag. When turned on, it can highlight all of your elements if you really wanted to for each of your step actions. Another way to do this, to add additional information, is growl notifications. And the little growl notifications, the things that pop up as a little dialog box, at least on Mac, that's how it is. I'm assuming it's on Windows too, that says, hey, here's some important information from this application. And there's actually a jQuery growl library that we can use to have these little informational tidbits pop up in our test within the DOM of the page we're testing. And so if we set that up, we just have a simple test like this that goes to the home page of the internet and then clicks the last link on the page. As we create an instance of Selenium to connect to a remote node, we can pass it a listener, which is this thing right here. And I have this class called the growl wrapper, which what it does is it extends the abstract event listener in Selenium. And within Selenium, this abstract event listener gives us access to all of the actions within Selenium, basically things around it. So after navigating to a URL, before finding an element, after finding an element, clicking, etc., we can actually drop in this growl notification, have it display the information that the test is taking. Again, this is something we can add as setup for our tests for some kind of debug flag to provide us more robust information. And the actual add growl method I made as a private method since some gnarly JavaScript that we just kind of hid behind the covers. But what it's doing here is it's making sure that jQuery is actually loaded on the page we're testing. And if it's not, it's injecting it. And then after it injects the jQuery growl required bits in order for it to work. And then we have display growl, which is executing this message on the page using jQuery growl. And then it's making sure it displays on the page for half a second before going away. And so what that looks like applied is this. So we have a test that just goes here. This is the test running that I just showed you, and it's displaying all of the different steps that are happening as they're happening. And so again, between highlighting the element and doing something like this, we can get a very interesting narrative very quickly within a video or screenshots of what's actually happening in our test. And if there's a failure, then that's one way to hopefully give you more than enough information to spot what the issue is. And so again, if you watch this and you feel like, yeah, but I'm new to Selenium, how do I get started? Again, I encourage you to check out my Selenium Bootcamp, my guidebook, the free sample, the first 6 chapters, which are available at this URL, and my weekly Selenium tips, which, again, Elemental Selenium, free once weekly tip. And if you're interested, I actually am in the process of converting the tips. I've open sourced them at this link on the bottom right, bit.ly/OSS, short for open source software-es-tips. So check that out. It's all the tips up until it's all current, and I'm having anybody that submits pull requests into their preferred language. If I accept the pull request, I'll do a write-up. Basically, so if you find something in Ruby and you're like, hey, I know how to do this in Java, then please, by all means, take a look at this link and send me a pull request for the code, and then I'll do a long form write-up, and then I'll give you a shout out, a big thanks on the tip on the website. But if you have any questions, please feel free to get in touch. This is my Twitter, my email, and my website, where I have a link to that has free open office hours. Every couple weeks I schedule a couple of hours, make myself available for half-hour chunks of time to try to help people step through any specific testing challenges they're facing. If it's just, what do I, maybe you have a very specific technical issue you want help with, or maybe you're just not sure how to get started, or whatever it is, like, I'm happy to help. My goal is to be the most helpful person in Selenium, and so I try to make myself as available as possible. So feel free to email me questions, schedule office hours, tweet at me, whatever it is, I'm available. So so that's it. I hope you enjoyed this webinar. Thanks to Applitools and Sauce Labs for organizing, and looking forward to talking to everybody. All right, thanks. Take care. Bye.